Very important sum of two proof type, right? The sum says we have to prove that 1 plus sec a upon sec a is equal to sine square a upon 1 minus cos a. Now here we have to first decide which side to select, the left hand side or the right hand side. Remember, I told you something. First check which side has the secondary trigonometric ratio. Secondary trigonometric ratio is nothing but tan, cot, secant, cosec. Which side has it? Yes, it is the left hand side. Beautiful. So we select the left hand side. So that is going to be 1 plus sec a upon sec a, right? The next thing which I said is, once we select that, try converting that secondary trigonometric ratios into primary ratios, that is sine and cos. So 1 plus sec a will be written as 1 upon cos a, right? Same way in the denominator, sec a will be written as 1 upon cos a. So the numerator, that is what we have there, that is 1 plus 1 upon cos a divided by 1 upon cos a. It is always better when you have fraction upon fraction, write it in the horizontal form. It's easier to solve the sum. You'll never make mistakes. Let's solve it further. In the first bracket, we have to take LCM, right? So we take the LCM there. So we'll get cos a into 1, that is cos a, plus 1 upon cos a in the denominator and divided by 1 upon cos a. When we convert that into multiplication, it would be the reciprocal. So cos a goes in the numerator, 1 comes in the denominator. That is what we have. What happens further? Yes, cos a and cos a gets cancelled. So we have 1 plus cos a upon 1. Now observe very carefully. We have solved it. Say, so this was very easy. We got up to this. It's not over because we are solving the left hand side to get the right hand side. And we have not got the right hand side. In the right hand side, we want 1 minus cos a in the denominator. Observe. Right? And have we got? No. We have got 1 plus cos a, but in the numerator. But I want 1 minus cos a. So when you're solving a left hand side, keep a watch on the right hand side. See what you want in the right hand side is 1 minus cos a in the denominator. Try getting that. How will you get that? If you want that in the denominator, you will multiply that in the denominator and in the numerator. So that is what we are going to do now. So we'll multiply and divide this by 1 minus cos a. Now we do that. So what do we get now? The next step we would get here is nothing but, see what we get is nothing but 1 plus cos a we have, right? We are going to multiply and divide by 1 minus cos a. So 1 minus cos a in the numerator and 1 minus cos a in the denominator. Beautiful. So what do we have in the numerator now? 1 plus cos a into 1 minus cos a upon 1 minus cos a. This is what we have now. Now observe the numerator, identify that algebraic expression. Observe, it is nothing but a plus b in the first bracket. The second bracket is nothing but in the form of a minus b. What is a plus b into a minus b? It is nothing but a square minus b square. So we write it that way. So it will be 1 square minus cos square a. And in the denominator, it is 1 minus cos a as it is. Still it is not over, right? But on the right hand side, we want in the numerator sine square a. And rather we have here 1 square minus cos square, that means 1 minus cos square a, right? So we don't want that. We need to write it in the form of sine square. Can we get it? We have an identity which we have learned, right? We know that identity. Sine square a plus cos square is equal to 1. From this, I need to know what is 1 minus cos square a. So shift that. That means I'll get 1 minus cos square a is nothing but it is sine square a, and here we have sine square a, right? And in the denominator it is 1 minus cos a. So we have here the right hand sides are equal. So we got the right hand side here, that is equal to RHS. Hence we have proved that 1 plus sec a upon sec a is equal to sine square a upon 1 minus cos a. Wasn't that easy?